In this video, I'm gonna explain for you transformations. Students, as you know, transformation have a lot of type like translation, like reflection, like symmetric, like compression and stretch, and so on. But in today's lesson, I will just explain translation and the second one, compression and stretch. So let's begin. Students, translation have a vertically translation and horizontally translation. For horizontally translation, you need to think about left and right. But for vertical translation, you need to think about up or down. And for each of them, we have our own rule in order to write. For example, in translation horizontally, what will happen to f of x, the function? It becomes f inside. Please, horizontal, think about inside. Because all the process is going to be inside the function. Inside. But for vertical, going to be outside. Okay? So, this x inside the f, we plus or minus a number. Let's say b. This number, students, when you plus by b, will move or shift your function to the left side, opposite. Tamam. Even though this is positive, but we'll move to the left. It was in inside. For the negative, we'll move your function to the right, your graph to the right side. How about vertical? What will happen? Vertical is outside, means f of x. What will happen to f of x? We will add or subtract this function by something. Let's say by k, or by any other letters. Let's be different than b. So, but with the same. When it's positive, it goes up. When it's negative, it goes down. So this is the basic of translation. I'll say it again. Left to right, horizontal. Up or down, vertical. Tamam? Up or down is vertical. For horizontal, going to be inside, you will add or subtract by a number, your x. But whole function in vertical, you will add or subtract by a number. Plus mean up, minus mean down in vertical. Plus mean left, opposite, let's say, and minus mean right in the horizontal. Let me show you by graph. Dear students, if we have f of x equals, this is example, f of x equals x power 2. We all know the graph going to be the parabola, right? The graph going to be like this. Correct? On 0. But what if I translate this function? What if I translate it horizontally? H mean horizontally, like, مثلا if I make it f of x equals, or if I want to find f x minus 2, x minus 2, so going to be x minus 2 square, right? So what will happen to the graph, dear students? The graph will move, as I told you, this is inside, right? So we'll move 2 units to the right or left. Since it's minus, we say minus goes to the right. So we'll move 2 units to the right. So this is 2. And the graph going to be the same. How about vertically? What will happen to vertical? Just quick example. If I have vertical, f of, let's say, x plus 3. So what will happen to this one? Equals x power 2 plus by 3, because your f is x power 2, right? Plus 3 equals x power 2 plus 3. Okay. This is mathematically not correct to write like this, but just for understanding. So this is the idea. we added the function by 3. So what will happen to the graph, dear students? We shift. This one was our original function. This is our original function, right? So how we shift this function? We shift 3 units up because this is outside. True? So going to be 1, 2, and 3. So the graph going to be here. This is horizontally shifting. Vertically shifting. Dear students, let's take this example. This example saying given that f of x equals x plus 3 when x greater than 0 and 2x plus 3 when x less than or equal to 0. Write the rule for G, a horizontal translation. So look at here, saying horizontal translation. Horizontal we say either left or right. True? For left we plus, for right we minus. The translation 4 units to the where? To the left, to the right. So to the right it means we need to find f of x minus 4. We say since it's horizontal going to be inside, and since it says to the right, so we will find f of x minus 4. So what will happen to this function, dear students? We will say f of x minus 4 equals, in a place of each x that you see here, let me mark for you, all of these x's you must replace by x minus 4. So dear students, what you will get, let me rewrite the rest. Plus 3, and here we have greater than 0, here we have 2 brackets. I'll just leave space for x's and less than or equal to 0. So for these x's that I circled, I'll write x minus 4, and here also x minus 4, here also x minus 4, and here also we have x minus 4. So simplify, final answer you will get x minus 4 plus 3 going to be x minus 1, and move 4 to the other side, going to be x greater than 4. 2 times x, 2 times negative 4 equals 2x. 2 times negative 4 equals negative 8, with 3 going to be negative 5. And move 4 to the other side, going to be x less than or equal 4. Dear students, let's talk about a little bit about compress or compression and stretch. For compression or compress and stretch, again we have horizontal and vertical. And for each of them, of course, we have our own rule. Again, remember, horizontal going to be inside. Inside, the whole process going to be inside, but vertical going to be outside. All right? Okay. For horizontal students, we have f of x. What will happen to f of x? We will substitute in a place of x inside 1 over bx, where if the value of b was greater than 1, so this is stretch horizontally. But if this value was between 0 and 1, so this is going to be compress or compression. Let's write down compression. Same thing for vertical. Vertical is outside. So what will happen to f of x? We will multiply the f by a number outside. If this number was greater than 1, so this is stretch. If this number was between 0 and 1, this is compress. Dear students, we have an important note before showing you by graph what will happen horizontally stretch or compress, also vertically. In horizontal stretch or compress, just change the value of x in your table, or just x value is gonna change. But in vertical compress or stretch, y gonna change, or change the value of y. Okay, dear students, let's understand from this one. I will try to explain one for horizontal and one for vertical for better understanding. So, dear students, the question is saying graph the following. First one, you have f of x equals x power 2, and the second one, horizontal compression by factor of 1. Horizontal compression for f of x equals x power 2, okay? So first, let's graph x power 2, then the horizontal compression for x power 2 to see by factor 1 over 2. Horizontal compression, students, we say the factor is how much? Is 1 over 2. So when you write in the rule, this is going to be f of 1 over 1 over 2 x, right, which is equal to f of 2x, correct? So I told you right now, I said that when you have horizontal stretch or compress, just change x value. So all you need to do is what? Multiply your x values by 1 over 2. So when you multiply these x values by the given factor, so you will get the compression in the graph. So let's start. But let me change the color for you. Okay, so negative 2 times by 1 over 2 by the given factor, so going to be negative 1. Negative 1 times equal negative 1 over 2. 0, 1 over 2, and 2 times 1 over 2 equals 1. So let's graph both of them and let's see the difference. Okay, students, here's the coordinate. First, let's graph x power 2, then the stretch f of 2x. Let's graph both of them. This is f of x, this is f of 2x, this is f of x. Okay, so for negative 2, we have 4, so this is negative 2, and for the coordinate x and y. Then we have negative 1 and 1, so this is negative 1 and 1, 0, 0, 1 and 1, 2 and 4. Join all of these points together, you will get U-shape, right? So this is the graph of x power 2. Students, how about if we graph the compression? Remember, the compression, we say horizontally will get smaller or more narrow. So negative 1 and 4, so this is negative 1 and 4. We have negative half, which is here, and 1, negative half and 1, 0, 0, 1 and half, and we have 1 and 4. Join them all together. So obviously, this is horizontal compression, right?